Hey pre-algebra, we are in chapter 4, expressions and equations, and we're working on two-step equations. We're going to be solving two-step equations in this section. We have only only one vocabulary word here, and that is, what is a two-step equation? And really that's just an equation that requires two steps or operations to solve. So for instance, we've been talking about equations that look like this: 2x is equal to 9, or 5 plus m is equal to 7, where we really only have to do one thing. Like on this side we only divide, and on this side we would subtract 5 from both sides. But now our two-step equations might be something like this: 2x plus 5 is equal to 7. So not only do we have one thing, division, to do, we're also going to have like subtraction. So that's a two-step equation. So let's get right into solving. In this first problem, let's call it part A, we have 3a plus 9 is equal to 33. So what we need to do is to actually isolate the a. In order to isolate the a, I'm going to rewrite the equation. In order to isolate the a, in a sense, we've got to undo what's happening to a. So in a way, we kind of go in reverse of PEMDAS. So instead of undoing multiplication first, we're going to undo the addition first. So the first thing we're going to do is to get rid of the 9. I'm going to add a negative 9 to both sides. Remember, what I do to one side, I must always do to the other. So on the left side, I'm left with 3a. These guys have canceled each other out. And on this side, I have a positive 24. Remember, we're adding the opposite. So I'm taking 33 and I'm adding a negative 9. So I'm adding that negative. What I need to do now is divide both sides by 3. Who's bothering a? 3 is. By what? Multiplication? The opposite of multiplication is division. So I divide both sides, and finally I'm left with a is equal to 24 divided by 3 is 8. So those were the two steps we needed for our two-step equation. Let's come over here and look at this problem. So this is our part B. I need to get x by itself. X is being bothered by 4 and minus 5, but I'm going to get rid of that minus 5 first by adding the opposite. So I'm going to add a positive 5 to both sides. What I do to one side, I do to the other, but here I'm doing it to get rid of this minus 5. That's gone, and I'm left with 4x is equal to a negative 33 plus a positive 5. What that's going to leave me with is a negative 28. Because when I add two numbers with different signs, I subtract and take the sign of the higher number. My next step is to get rid of that 4 that's multiplying next to x, and I'm going to do the opposite and divide both sides by that 4. The 4's cancel out, and I'm left with x is equal to negative 28 divided by 4, which is a negative 7. Here in example 2, we have another type of two-step equation that looks a little bit more complicated because it gives us this fraction vibe, but we can still handle it. We're going to do exactly the same thing we did last time. So here in example 2a, I'm going to draw a line through the center, and what I do to one side, I do to the other. I know I keep repeating that, but I don't want you to forget it. So what I'm going to do is isolate this p term, which is p over 5. I'm going to isolate that term by adding 12 to both sides. I'm doing the opposite. Where it said subtract 12, I'm now going to add 12. So that cancels that out. So on the left side, I have p over 5, and on the right side, I have 20 plus a negative 12. 20 plus a positive 12, which gives me 32. So if p divided by 5 equals 32, how do I undo this? If 5 is dividing into p, the opposite of division is multiplication, I'm going to multiply that dividing 5 away. What I do to one side, you guys got it, I got to do to the other. So when I cancel out those 5s, I'm left with p is equal to 5 times 32, which is 160. This next part B, we're going to take it very similar to the way we handled this first problem. So the first thing that we're going to do is recognize that this is the n term, n over 3. That's my variable term. I'm going to leave that alone and get it by itself. So I do that. I'm going to draw a little line. I'm going to subtract 15 from this side, and I'm going to subtract 15 from this side. So a way of looking at subtracting 15 is adding a negative 15. So I'm adding negative 15 to both sides. When I do that on the left side, I'm left with a negative 7. And when I do that on the right side, I'm left with n over 3. So n over 3 is equal to negative 7. What's 3 doing to n? It's dividing. What is the opposite of division? It's multiplication. So I'm going to multiply both sides by 3. I'm undoing this division by multiplying. So on the right side, I'm left with n. On the left side, I've got this guy here, 3 times a negative 7, which is negative 21. And I'm done. N is equal to negative 21. I need you to pay special attention to these examples in example 3. Please watch. I'm going to actually rewrite this first one. Let's call this A. 9 minus t is equal to negative 34. Now this looks really simple. It looks kind of like a one-step equation, but there are 2 steps, so I need you to be aware. So what we need to do is isolate our variable. Our variable is t. We want to get t by itself. I'm going to get rid of the 9. The 9 is a positive 9, so I'm going to do the opposite of what that 9 is and add a negative 9 to it. When I add 9 and a negative 9, they go away, and I'm left with a negative t right here. Remember, we are now carrying along that operation sign in front of a number as if that sign is the sign of the number. So that minus t, I'm looking at that as a negative t in a sense. And that is equal to, what's negative 34 plus negative 9? That's going to give me a negative 43. And so at this point, it looks like I'm done, but I'm not. I don't have t isolated. I have negative t isolated. To isolate t, I've got to get rid of that negative next to it, so I'm going to divide by a negative 1. What I do to one side, I do to the other. Notice that negative 1 cancels out the negativity of the t, and I have t left by itself. Negative 43 divided by negative 1 is a positive 43. T is equal to 43. You can actually check all of these by taking your value for t and plugging it right back into the equation. Let's take a moment and do that now. So I have 9 minus t, but now we're going to put in 43 because that's what t is. So 9 minus 43 is equal to negative 34. Remember, guys, all we're doing is checking here to make sure that our answer makes sense. 9 minus 43, well, that's really like 9 plus a negative 43, which requires me to subtract and take the sign of the higher number. When I do that, I get a negative 34, and that's exactly what I was expected to get. And so that gives me confidence that the work we did in solving is absolutely correct because our check came out right. So anytime you have a concern with the answer you get, plug it back into the original equation, evaluate it, make sure it makes sense. Let's go on and try part B. So if you notice, we've got a very similar situation. We need to isolate this n term that's over here. To isolate that, I've got to do the opposite of what this negative 4.3 is doing. I'm going to add a positive 4.3. I'm going to do that to both sides of my equation. I like drawing a line, friends, so I'm going to do that. When I do that, these guys cancel out. My right side just has a negative n. Remember, we're carrying that operation sign around. And now negative 6.5 plus a positive 4.3 is going to be a negative 2.2. When the signs are different and I'm adding, I subtract and take the sign of the higher number. Are we done? No, we're not. We have isolated a negative n. That's not what we're interested in. We are interested in isolating a positive n. So I'm going to divide both sides by that negative 1. Like we talked about before. That cancels out. Boom. I'm left with a positive n is equal to 2.2, positive 2.2. And that's my answer. Again, feel free to go ahead and plug in 2.2 in for n to the original equation and check. In this final example 4, we're going to combine like terms before solving. So I want you to take a look at what we have here. This equation, 2x plus another x minus 27 is equal to 3 should be simplified on both sides before we even start trying to solve. So what I'm doing right now is I'm looking at the left side of the equation and I want to join like terms. This is 2x, and I think you guys all know that this is like 1x. That looks terrible. My apologies. Get rid of that. Okay, so this is just 1x. All right, so 2x plus 1x gives me 3x minus 27. What I do first is I just look and I say, have I simplified this side of the equation enough? I can't do any more. I'm feeling satisfied, and I move on to the other side. Clearly this 3 cannot be simplified anymore. And so now my equation is ready to be solved. I'm going to isolate my variable term. The term 3x is my variable term. So I'm going to get rid of everything else. I'm going to move it to the other side. This minus 27, to get rid of it, I'm going to do the opposite and add a 27 to both sides, add positive 27. When I do that, I'm left with 3x on this side, and that's equal to 27 plus 3, which we all know is 30. Very simple math here. We're going to divide both sides by 3 because, again, we want to isolate x. And what's 3 doing to x? It's multiplying. What do we do to get rid of multiplication? We divide. So when I do that, x is equal to 10. And I'm done. All right, guys, so we have come pretty much to the end of this video and almost to the end of the chapter. Please observe the assignment. Make sure you get as much of it done as possible. Section 4.6 will be posted soon. Make sure you get all your notes and your assignments done. They'll be due soon, and a test is forthcoming. Have an excellent day.